Good evening, San Diego. Welcome to Channel 4 News. I'm Ron Burgundy. Tonight we will be interviewing two experts in the geothermal industry, asking the critical questions our viewers are wondering. Allow me to introduce Brick Tamlin, our expert in residential systems, and Veronica Corningstone, commercial geothermal systems expert.
You're not Ron.
Let's start off with the most frequently asked question. How much will it cost to install this system?
Well, there are quite a few factors that play into the upfront cost, such as conditioned space, space available, seasonal temperatures, and soil composition. An average price one might expect would be from $10,000 to $18,000.
Veronica, you don't look satisfied with that answer. Would you like to elaborate?
Well, Brick has completely missed some of the largest expense factors. Depending on your location, finding a drilling company with proper certification may require large transportation costs. These companies are typically located in large cities with higher cost of living, so customers located in rural areas will have higher costs. A more realistic price range would be from $15,000 to $25,000 for residential applications.
This seems very expensive for a system that will require backup or supplementary HVAC equipment. Why should buildings use ground source heat pumps?
First and foremost, it is a long-term investment. Buildings that integrate geothermal systems have the ability to pay for themselves within 20 years, if designed properly. The efficiency of these heat pumps are in a class of their own.
Yes, I've heard reports of systems having efficiency ratings over 300%. How is this possible?
Understanding how efficiency is measured is important. When you hear of these ratings, it is important to understand that resistance electrical heat is the standard efficiency measure, which is 100%. All other heating and cooling systems are compared to this standard. The efficiency is a ratio between the amount of BTUs the system can move and the amount of BTUs the system requires to operate. Since ground source heat pumps use the earth as the BTU supply for the system, this number is not added to the input requirements of the system. This leaves only the electrical demand as the input, whereas other system would have to incorporate the BTU input of fuel. Some heat pumps even change the standard efficiency value of electric resistance to include transmission losses for our inefficient grid. By doing this, some systems are able to boast ratings as high as 600%. This is one reason it is important to look more at the capabilities of a system when selecting equipment rather than the efficiency alone.
Incentives are another good reason to install a geothermal system.
Yes, Brick, incentives are another reason for installation. So, should every existing building retrofit for a geothermal system?
The dedicated outdoor unit which is required for maintaining efficiency requires the use of centralized ventilation systems in buildings. This is where the outdoor supply air can be pre-treated through the use of ERVs, like an enthalpy wheel.
This is not true. Even buildings with zone-specific outdoor units can be retrofitted with a geothermal system. They do pose more difficulties, but provide a cheaper installation cost. The only true hindering factor as to whether a geothermal system can be installed is the available space. Parking lots can provide space for the geothermal loop, but many buildings don't even have this option.
Interesting. What about new constructions? Veronica?
To maintain our nation's integrity as an energy leader, we need to integrate every energy savings potential through smart building practices. This includes the utilization of geothermal systems, since they fall under renewable heat sources, providing a free source of energy. Continued dependence on fossil fuels can only lead to higher operation costs as geological reserves deplete.
The use of geothermal systems reduces the size requirements of equipment. This allows for more usable space in the building by the reduction of mechanical room sizes.
Yes, that is a good point, Rick. You mentioned space requirements of geothermal systems. I saw a system being installed where a large area of the property was being dug up. How can all buildings use geothermal if they have limited space available?
There are actually 4 types of geothermal loop strategies. The vertical well design is a series of vertical pipes connected in series to one another. This has the potential to raise the temperature of the ground if not properly designed. This linky design is a spiraled pipe that is laid in a trench system. This can also be applied in a body of water. The last type is an open loop system.
I love open loop systems.
Do you even know what open loop systems are?
I love open loop.
Open loop system use 2 separate wells, one for drawing water and another for discharging back to the water table. This system is not often used because of risk of contamination.
We're at 6 minutes.
That's very interesting. Brick, please shut up from now on.
Okay, Ron.
So, Veronica, how does geothermal equipment compare to standard commercial HVAC equipment?
In a geothermal system, the primary boiler is replaced with the geothermal loop and water source heat pumps. Since the geothermal loop supplies heat to the system, the fuel requirements are eliminated, making the equipment incomparable. Geothermal systems use a heat recovery chiller to replace the conventional cooling tower and chiller. The operational costs of heat recovery chillers are lower because the geothermal loop provides a constant temperature, reducing the cooling load by allowing heat rejection to occur more effectively.
So are geothermal systems used for primary heating and cooling, or are they simply to be used as a supplementary system?
For residential and light commercial applications, geothermal systems can be designed to supply the adequate heating or cooling load for 80% of the year. However, secondary or supplementary equipment is always needed, such as an auxiliary boiler. For larger systems, the geothermal equipment typically only provides supplementary heating and cooling.
What do you feel the biggest difference is between residential and commercial systems?
Residential applications typically use a packaged geothermal heat pump which supplies conditioned air through ducting. Also in use are packaged units which supply conditioned water, which can be supplemented by a water heater for radiant floor heating. Commercial systems have a much more complicated design known as a central geothermal system. All the components of this system are separated so that they may be integrated with building automation. The geothermal loop uses water pumps to bring the water to heat recovery chillers, which also can provide heating. This is then distributed to central air handlers, which can provide heating or cooling. The four-pipe design allows multiple air handlers to run even if some require cooling when the rest supply heating. VAV terminal units are placed throughout the building which can supply heating or cooling independently. An auxiliary boiler is tied into the heating loop for peak heating demands. Some systems use a cooling tower. However, if this system is designed properly, all heat is stored geothermally and would not require the additional heat rejection system. Another strategy for commercial applications is distributed geothermal systems. These use water source heat pumps in each zone. This system can be used without centralized ventilation systems. However, this system has many disadvantages since the heat pumps are placed directly in a space. Maintenance can be a hassle. Also, since this system is not taking advantage of centralized ventilation, each heat pump will need a dedicated outdoor air system. In addition, this will limit filtration possibilities as well as reducing the efficiency of energy recovery strategies.
Well, I don't know about the viewer, but I learned a lot tonight. I would like to thank my guests, Veronica and Brick. Brick, get out here.
Oh, yeah. Okay, thanks.
Thanks for having us.
You stay classy, San Diego.